Hello, everybody. This is AVK Tailgate Talk. This is number 5, and we have John Wilber, Randy Looney, and Mark Tompkins. We're going to talk everything about gate valves, and it's going to be pretty impromptu. We really haven't rehearsed it much at all. So I'm in Nashville at the AVK warehouse, so there might be some echo here and there. I apologize. But we'll move forward. And so, again, if anybody in the future has any ideas for topics or whatnot, the AVK Tailgate Talk hat and polo is available for anybody that participates in these. And so the first thing we're going to talk about is OS&Y versus NRS gate valves. And I think most people predominantly in waterworks, we deal with NRS, like the valve on the left there, especially in buried applications, but we do from time to time treatment plants and whatnot see OS&Y. So John, what's your thoughts on the OS&Y gate valve and some tidbits about it? What makes it unique?
Well, the primary thing for an OS&Y gate valve is that when it's open, the stem is sticking up so you can tell it's an open valve. Or in the case of the one that's shown there, it's a closed valve. And another nice thing about OS&Y valves, if you're using them in wastewater treatment, is that there are no moving parts on the inside. There's no churning stem, no threads. The stem just slides straight up and down. So there's less chance of the stem getting interfered with by stuff that might be in the wastewater.
Mm-hmm. Okay. And we were talking when we did kind of go over this previously. If they wanted gearing on an OS&Y, is that an option?
Sure. We offer gearings for both of our valves, the NRS and the OS&Y. The OS&Y primarily has to be a bevel gear, so the hand wheel doesn't interfere with the operation of the stem. Occasionally, you can do a spur gear on an OS&Y, but it has to be a really small hand wheel so that the hand wheel doesn't hit the stem. And then for NRS valves, of course, we can supply both bevel and spur gearing.
And we see chain wheels from time to time on an NRS valve in a treatment plant, but they could do that on an OS&Y as well?
Yeah, they can, but the OS&Y valve and the NRS valve, for that matter, will have to be mounted horizontally.
Okay. All right. Well, we'll move on. If anybody has any questions about any of this as we're going along, feel free to put them in the chat and we'll go on from there. Mark, if you see a question or something, make sure you let me know.
Sure.
The wedge is pretty much the heart of the valve, especially on an AVK gate valve. And let's talk a little bit about the wedge, the design of it, the function of it, and how the resilient seat wedge kind of is, next generation over a metal seated valve.
Well, the primary thing about the AVK wedge design, as you can see in the center top up there, is that the wedge nut isn't loose. It is pressed into the ductile iron of the gate valve wedge. And we do that for two reasons. Number one, a loose wedge nut will sometimes wear through the rubber if it's open and closed quite a few times because it'll shift back and forth as the valve is open and closed. And the other reason is that there is no exposed ductile iron to the waterway. The rubber is vulcanized right up to the wedge nut. And another thing that we should say about the gate valve wedge is we do offer NBR and EPDM, and the vulcanization system that bonds the rubber to the ductile iron is proprietary to AVK. We blast it, coat it with 2 primers, and then we vulcanize it.
And the EPDM we use for potable water. NBR has a couple of applications for us. One is anything that has like hydrocarbons or something of that nature. I'm sure it would be applicable for other things as well. But what's the other really good application for NBR in our case?
Well, we like using NBR in wastewater because the fats and oils are in wastewater are also hydrocarbons, and they can attack and swell the EPDM wedge. EPDM, on the other hand, is excellent for drinking water because it's very resistant to chlorine, chloramines, and ozone.
Okay. Alrighty. So it's important for anybody that's listening to understand if you do have application where you might have hydrocarbons or something like that um, outside of the potable water window, AVK does have some options for you. And stem material is another one. We have a couple of options here, actually several, but the 400 series stainless is our standard stem for potable water. We also do a low zinc bronze stem, and then we have some other variations on those. Do you want to talk about that, John?
Yeah, for drinking water applications, the stem on the left, the 430F stainless steel, is an excellent stem. It's got very high strength, and that solves one of the problems a lot of people have with bronze stems, is that they will break if you over torque them. For wastewater applications, seawater applications, brine, produced water from fracking operations, we recommend that you use the low zinc bronze stem. We do this because some of those applications can be a low oxygen environment. And for stainless steel to remain corrosion resistant, it has to have oxygen to create that chromium dioxide layer on the exterior of the stainless steel. For low oxygen environments, brackish environments, high salt environments, the low zinc bronze stem is what we recommend for that, which is be better or superior to 316 and 304 as well for those applications.
Okay.
Stephen has a
Go
question.
ahead, Mark.
Yeah, Stephen has a question here. He says, can the valves be used in hot water applications? Are there temperature ratings for the NRS and the OS&Y? Are they the same?
The temperature ratings are the same, and the maximum temperature rating for the AVK gate valve is 160 degrees. It's primarily because past 160 degrees, the bond between the ductile iron and the rubber will start to degrade. And the hotter it gets, the faster it degrades. So like 170 degrees, they'll probably last you 5 years, 180 degrees a year. But that's never been tested, so don't take it to the bank. So our maximum long life operating temperature for AVK gate valve is 160.
And is a good question, by the way, Stephen. And another question, John, or topic on this. I guess the AVK stainless stem, from our point of view, and the strength of it and its ability to withstand torque, butterfly valves have always had a stainless stem. Is that correct?
That is correct.
Okay.
Yep, and they're also very high torque.
Yeah, for that reason. So
yep.
That's why they use that stem. So we just made it standard on our gate valves as well, and we've had great luck with that. So feel free to throw any additional questions at us. We're going to delve into end connections here a little bit, and you can see on the screen we have a variety flanged, and we have the 125, 150 pound flange. We have a 250 pound flange. We have push on by push on, obviously flange by MJ, MJ by MJ, the Hymax, groove by flange, and then also at the right center, you'll see a HDPE by HDPE end. So do you want to kind of touch on those and what the applications are for each connection, John?
Well, for above ground applications, primarily all joints are flange joints because you don't need flexibility in the joints. But you can use the Hymax by Hymax for an above ground application as well if you want to, and the fusible HDPE valve. And then for below ground applications, the joint of preference is push on or a mechanical joint or the Hymax because those joints can flex. So if the soils shift, the joint will still maintain its integrity.
And that's a little unique for us with the Hymax end, that it can be installed above ground. Some of the alternate products to that require the soil compaction to actually function as part of it as well, correct? I mean, ours being above ground with the restraints unique at this time.
I do know that our competitors recommend that they don't put their restrained 1-bolt connections above ground. But for us, that's no problem. It could be used either above ground or below ground. However, I am not sure of the reasons for that.
Yeah. Okay. And deflection wise, the MJ will allow a little bit of deflection as well, but
about 5 degrees. All those joints allow about 5 degrees of deflection when they're buried.
Yeah. Okay. All right, no additional questions at this time, so we'll move on to the next. Coatings, we have a number of options for coatings, but do you want to touch base on that a little bit, John?
Yeah, all of our coatings comply with AWA C550, which is the always standard for epoxy coatings for fittings and valves. And our minimum coating thickness is 10 mils. It will be a little bit thicker sometimes. For holiday free, it's a little bit thicker because it's got to fill in the peaks and valleys. Here we are checking for holiday free for our holiday free coatings. And I think that probably covers everything about coatings. Can you think of anything else to add, Kent?
Primarily, the holiday-free coating would be on the interior of the valve. We do, on occasions, get exterior coating requests, but it requires a lot of special handling and packaging.
It does. So if you want a holiday exterior coating, we should go to the next slide. And we offer a 60 mil thick polyurethane coating for the exterior for highly corrosive environments, as opposed to a holiday-free fusion bonded epoxy. Much more durable, much thicker, all around a better coating for the exterior of a valve. However, we do not supply it for the interior of the valve because the polyurethane is not NSF 61 approved for drinking water. Plus, it's too thick and it would interfere with the operation of the sealing of the wedge.
And this polyurethane coating is not just holiday free, it's also extremely strong, resistant to chipping, abrasion, and all sorts of things. So really nice option to poly wrapping a valve. Corrosion resistance is increased and a number of things like that. Anything else to add?
No, we should also, we also offer it for the base of the fire hydrant too. Okay. And not just for gate valves, we'll do it on butterfly valves, plug valves, whichever kind of valves you'd like.
Okay, so we're going to move on a little bit, talk about bypass kits. This is kind of an interesting topic from time to time, and we see them intermittently specified. We do a number of different options here, and let's talk a little bit, John, about the size range we have available and what the bypass primarily is used for.
Well, back in the old days when they had metal seated gate valves, they'd use them to equalize the pressure on both sides of the valve to make the valve easier to open and to make it less likely that if you had full pressure on that bronze seat that you wouldn't tear the bronze seat off when you open the gate valve. However, with a resilient wedge gate valve, that's no longer an issue. But you do use them to slowly fill a line upstream or downstream so that the air valves can handle the volume and you don't get water hammer problems. That one picture on the upper left there is a double block and bleed. The company we sold it to wanted it for safety reasons so that they would know they did not have any leakage downstream of the valve. So they would close both valves and open the middle valve. And if there was any leakage through one of the valves, it would drain out through the middle valve. Mm-hmm. The one on the bottom right, or the one on the right-hand side, it was a triple redundancy valve. One of our customers ordered. They wanted 3 bypass valves, not just one. In case after 60 or 70 years, one of the bypass valves failed, they would have another one. And we also offer our bypasses up through 18 through 24 inch. We offer the bypass spools like is shown on the right. And then 30 and 36, we offer bypasses like is shown on the bottom left. And we also offer bypasses on the sides and also the bottom of the valve if you want to bury the valve horizontally and have a bypass on it.
Okay. And let's talk just briefly about the size of the bypass valve we use, like on a 30 and 36 inch, and how we, size that.
There are bypass recommendations in AWA C500, which is the standard for metal seated gate valves. And we followed their size recommendations. So we comply with AWA's recommendations in all of our bypass sizes. I think an 18 is 3 inch, 20, 24, I can't remember the exact size, is 4 inch, 30, 36 is 6 inches. Mm-hmm. But don't quote me on that.
Yeah, all right. No other questions at this time, so I'll move on to the next one. And this is kind of interesting. We have the anti-rotation feature on the valves and the T-bolt used for MJ. And do we want to talk a little bit about, that part of it?
Sure. We had some complaints from the field when people were tightening it up Series 45 gate valves with the U-slots that the T-bolt would rotate out. So we offered this as a solution to stop the T-bolt from rotating out when you're assembling this in the field, which eases assembly and speeds it up a little bit.
Okay. And we also offer that on the fire hydrant inlet or shoe as well, and it's been very well received. Standards, kind of your wheelhouse, John. You used to work for AWWA and had a lot of input on this. So let's talk a little bit about AWWA C509 versus C515 and the differences between the two.
Yeah, back in the old days for resilient seated gate valves, the only standard was C509, and it was written primarily when gray iron was the dominant material. So the wall thicknesses were quite thick because gray iron is not that strong of a material. And then ductile iron came out, but the only standard that was available was C509. And AWWA doesn't really use performance standards. They used prescriptive standards. So they said this is what your wall thickness will be. So manufacturers said, well, we're making these things out of ductile iron. It's a far stronger material. There's no reason for the walls to be that thick. Why don't we create another standard, C515, for reduced wall thicknesses for all ductile iron valves? So that's what C515 is. It's ductile iron only. And C509 is both gray iron and ductile iron, and it has thicker walls. Should be pointed out that if you have a ductile iron valve that complies with C509, it does comply with C515 because C515 is a minimum wall thickness. And that's about the size of that one.
Okay. So to sum that up for everybody, our Series 45, which is a full wall valve, complies with C509, but it's made out of ductile, so it's also C515 compliant. Correct?
Correct.
All right. Moving on. No additional questions, but on the class 150, sometimes called a 125 flange, that's the one on the left. And then you have the class 250 at the right. And let's just touch a little bit on the differences. And it's kind of amazing. We sell more of the class 250 than people might think. And, what the applications are and what they connect to.
Sometimes if you have a high-rise building, you have pretty high pressures at the bottom of that building. So people would want a heavier duty flange or the heavier duty pipe that they're using there. So that's the valve on the right. That's a class 250 flange, which for ductile iron is rated for 500 PSI. We only rate the valve for 350 PSI because we really are unsure of the effects of 500 PSI water jetting underneath a partially open gate valve. And the valve on the left is your standard class 125, class 150 flange valve, which is rated for 250 PSI. Oh, and the valve on the right, I think I mentioned, is rated for 350 PSI.
Mm-hmm. Yep. Okay. And no additional questions on this at this time. And so now we're getting into a little bit more about the standards. We talked a little bit about the AWWA standards before. But now how this all ties in with UL, FM, and NSF.
So all of our valves for drinking water, NSF 61 approved, and NSF 372 approved, so they also comply with the low load requirements of the Safe Drinking Water Act. Some valves we make are AWWA compliant. Some valves we make are only UL, FM compliant, but don't comply with the AWWA. So when you're calling us, if you want like a drinking water application, order a valve that complies with AWWA because that would be the best valve for the application for drinking water applications for buried service and whatnot. For UL and FM, fire protection valves, those are kind of a commodity product. Once you're certified to UL FM, and there's a lot of people who are certified to UL and FM, then the only thing you have to go on is price. So if you want a cheaper commodity valve, ULFM for fire protection. If you want a high quality underground valve that'll last you 50 years for drinking water, then go with AWWA.
Okay. And then on NSF 61 and 372, the low lead requirement is not applicable or mandatory for gate valves, but do you want to touch real quick on how we comply to the NSF 372 or whether we do, I guess?
Yeah, we do. NSF 372 came out when the Safe Drinking Water Act was modified to change the lead requirements to 0.25% of the weighted surface area. And all of our valves already complied with NSF 372. We didn't have to change a thing because our gate valves use stainless steel stems, so there was no lead whatsoever in our gate valves to start with. Now, whether or not it's mandatory, you do have to comply with the low lead requirements of the Safe Drinking Water Act. NSF 372 certification just proves that you do.
Okay. Yeah. So wanted to make sure we pointed that out, that, it is NSF 372 certified, our standard gate valve, and always has been. So
always has been since the 1970s.
Yeah, it's really a nice feature. So even valves that you had in before NSF 372 being required, if they're AVK, they meet that spec.
As a matter of fact, the EPA, our House and Congress and the Senate, they exempted mainline gate valves 3 inches and larger from the low lead requirements of the Safe Drinking Water Act. Why they did that, I don't really know. But AVK gate valves do comply with the low lead requirements of the Safe Drinking Water Act, and they always have, even though we don't have to, which is a feather for our cap.
That's right.
Because the amount of safe lead you can consume is 0.
Yep. So a key thing that we wanted to point out here. And so moving on a little bit, we'll talk about ISO and what it is and how we comply, and the 2 ways we comply, 9001 and 14001.
I was just going to mention that ISO is a quality management system. ISO 9000 is a quality management system. ISO 14000 is an environmental management system to not polluting or contaminating the atmosphere or the location you're working in. And AVK is certified to both.
Okay. Well, we don't really have any additional questions at this time, so we're going to wrap it up a little bit. We'll stay on here for a while, and if anybody does have questions, feel free to ask. Yeah, and if you log on later and are looking at this when it's not being recorded, if you want any of the handouts, reach out on AVK's website. You can go to contacts, find your territory manager for your region, and we'll get the handouts to you. So that's it for now.